Good morning to all. In the previous sessions, we began modeling of signals in signals and systems. This class is in continuation of the previous sessions. Now, we are going to discuss unit step function, unit impulse function, exponential functions in this session. Okay, let us start. Let us start. In this one, in the topic of modeling, of signals, now just we are going to discuss three important functions. One is unit step function. Second one is unit impulse function. Third one is exponential function. These three signals models now just we are going to discuss in this session. Now first one, unit step function. The first one is called unit step function. Now, actually, this function is called Heaviside unit step function. Heaviside unit step function. This actual name is Heaviside unit step function. In electronics and electrical and instrumentation, just we are calling it as simply unit step function. Now let us consider there are three important words here. Unit step function. Among these three, the only one important word is called unit. Unit means what? Of unit measurement. Now just look at. Now just we have to discuss this function with respect to continuous time signal. Now after that we are going to discuss the same concept with discrete time signal. So now students have to remember that under the concept of modeling, now just today we are going to discuss three important modeling signals. The first one is called unit step function. Its actual name is Heaviside unit step function. Whenever we discuss these three functions, we are considering both continuous time signals as well as discrete time signals. So under these two headings, we are discussing unit step function. For example, look at. Now, first we are discussing under the concept of continuous time signal. Now, let us consider a continuous time signal, t of t. In general, we are using what? In remaining cases, we use x of t, but this is unit step function. So especially here, we are using u of t. This point students have to remember. This is unit step function. Under unit step function, we are going to discuss under continuous time signal concept and discrete time signal concept. Now just let us begin with continuous time signal. This t represents continuous time. Because of unit step function, because of its uniqueness, we are using u of t instead of x of t. Now just look at, give the time measurements 1, 2, 3, 4, 5, etc. Similarly, -1, -2, -3, -4, etc. Now just look at. Whenever t is less than 0, that means up to this one. Whenever t is less than 0, up to this one, its value is 0. Let us consider the thick line I am drawing. look at, for all the values of t which are less than 0, its values are 0. This thick line represents 0. Whenever it reaches 0 onwards, now it suddenly raises to the amplitude 1, and continuously for all values of this, the graph continues like this. Look at, up to this, that means up to these values, its value equal to 0. But when it reaches 0, suddenly it raises to an amplitude of 1. And for all the values, the same amplitude continues for 1, for 1.2, 1.3, 1.5, etc., 1, for 2, 1, for 2 to 3, 1, for 3, 1, for 3 to 4, 1, for 4, 1. In this way, for all values, it ranges like this. This is unit step function. So students have to easily understand the concept like this. This is the simple concept of unit step function. Students have to understand like this. Now comparing this one, now just look at how to give a mathematical notation to this one. How to give a mathematical modeling or notation to unit step function. This is very much important. Now just look at, we are denoting unit step function by u of t. U of t equal to 0. When for all values of t which is less than 0, its value equal to 1. When for all values of t greater than or equal to 0. This is the mathematical modeling of unit step function under the concept of continuous time signal. Now just look at, students have to remember, first you have to observe this thicker line. The purpose of drawing or sketching this thicker line is that for all values less than 0, all are 0. That's why these values are remaining on only on t axis on the left side. Whenever the t value reaches 0, immediately it spikes. It spikes to which value? 1. Therefore, here the amplitude is what? The amplitude is equal to 1. That's why, because of the unit amplitude, we are calling this function as unit step function. Now just look at, for all the values of t less than 0, it is moving like this. Whenever it reaches 0, suddenly it steps up. Look at, steps up. That's why the name is called step. It is a mathematical description, so it is a function. So unit means what? Amplitude is equal to 1. Step means what? Moving up one step. Only one step ahead. Next, the remaining is parallel. It is modeling by a function. Therefore, we call it as unit step function. This is the way of understanding this unit step function. Students have to understand unit step function design like this. Yes, English S type, for example, like this. This is called unit step function. The same concept, now just we have to going to discuss under discrete time signal. Same function under discrete time signal. Now just look at, now under the concept of discrete, time signal. Now just look at how are we drawing this one. This is the same graph. Because of discrete nature, we are using not t, we are using n. Now, in the previous case, we used u of t. Now, just we are using u of n. This is the difference between continuous time signal and discrete time signal. Now, just look at here. Give the values of t 1, 2, 3, 4, 5, 6, etc., etc. Here -1, -2, -3, -4, -5, etc., etc. Same thing. Now just look at, this is discrete. So it considers only integer values, not all values. In the previous case, it considers not only integers, but also decimal values too. But here, there is no question of decimal values. It considers only pure integers. That's why, as long as t is less than 0, value is 0. Look at, I am not drawing a thick line. Students have to understand, I am not drawing a thicker line. Just instead of that one, I am making only round bubbles like that, thick bubbles. Now, for -3, 0. For -2, 0. For -1, 0. But whenever it reaches 0, it spikes. It spikes to which one? Amplitude 1. And for all values, this one, -1. Now just look at. Now again, next integer 2, same level it maintains. For all the remaining one, it maintains the same height, amplitude height like this. For all other values, like that. Now look at this one. This is the comparison between continuous time signal and a discrete time signal. Students have to understand, same shape, but it is continuous. It covers all points, but that is discrete. It covers only integer values. Now just look at. This also like this, purely like this. Here also like this. Both are same. But here, no continuous. Between -5 and -4, no representation. Between -4, -3, no representation. Between -3, -2, no representation. Between -1, 0, no representation. Now just look at. Here also, between 0 and 1, no representation. Only representations are at only 0 integer, 1 integer, 2 integer, 3 integer, like this. Just looking at the level of this, all these spikes, that is equal to 1. So amplitude is equal to 1. Now just look at, here we are using u of n. U of n. Now comparing this one, how we are using this one? Here we are using u of t. What is the mathematical modeling of discrete time signal? U of n is equal to 0 for all n values less than 0. Its value equal to 1 for all values greater than or equal to 0. Now, students have to make a comparison between these two. There is no difference. It is here integers plus decimal values. There it represents only integers. So that one, this is t. Here we are using n. Now look at same graph, same representation. This is a mathematical representation of unit function under continuous time signal, the same unit function under discrete time signal. Now look at the comparison, same thing, just we discussed. In the next session, now we are going to discuss unit impulse function. Thank you.